this podcast has to do with, again, trends. It's kind of a set of 3 podcasts that all have to do with trends. And today's trend is ionization energy. And if you have a pretty good handle on size trends, ionization energy becomes really, really, really easy. So, with ionization energy, the main thing is we need to define this. So ionization energy, just as a definition, is the amount of energy required to remove a valence electron, or just the outermost electron of an atom, alright? And then obviously when it loses that electron, it becomes an ion. But again, the definition for ionization energy is the amount of energy required to remove a valence electron. And it kind of makes sense because it's energy, and it's ionization energy, so it's the energy required to make something an ion, okay? And in this energy, it's always going to be a cation because we're always removing electrons, alright? So, this is really best explained just with like me in front of you. However, I'm not in front of you. So, if we kind of draw the periodic table real quick, and just kind of map this out, and we kind of have kind of something like this. And if we think back to size, all right, with size, we were able to make kind of 2 big trends, and our trends were up here at the top, we have our smallest atoms, top right, and at the bottom left, we have our largest atoms. When I remember this, I think francium is down here, Fr. Think fat radius, alright? So it has the biggest radius. And then we have helium up here, which is our smallest, okay? And we're going to say that just as far as trends go. Hydrogen is actually smaller than helium, but we're going to pretend hydrogen doesn't exist right now, okay? So, with that said, our largest is francium, smallest is helium. So if I am francium, I'm this huge, big, fat radius atom, and I have electrons that are way, way out away from me. And we'll just pretend my pin is my electron, right, and it's way out here. Would it take much energy to knock this pin out of my hand? It's way out there, it gets knocked out with not much energy at all. How come? Because my protons are so far away from my electrons. Really, they're really, really, really close because we're talking about atoms. But compared to other atoms, francium's electrons are a long ways, the valence ones, those furthest electrons, are a long ways from the nucleus. So it takes a little bit of energy to knock that electron away. Alright? So, largest atoms have small IE, and IE is just going to be ionization energy. However, if I'm talking about something like helium, its electrons are like right up close, alright? So try to take this electron from me. And it's going to be hard to pull it away because I have it so close to me. So again, helium, it's really attracting those electrons really, really strongly. It's 2 protons attracting 2 electrons, and they're both in the 1s orbital. So we're not even going out to the 2s or the 3s, or francium down there on the 7s, okay? So they're really, really close. They're really, really attracted. So it's going to take a bunch of energy to separate that electron from the nucleus, okay? Just because of their proximity, of their closeness to each other. So if you're on smaller, we're going to put large IE. So really, if you know the trends for size, the trends for ionization energy are exactly opposite, okay? So if we do period, and again, periods are rows, so if you want to add row across there, you might add row. But periods, so we were just going to say from left to right. IE increases. How come? Because from left to right, our atoms get smaller. And then our other trend, if it's not the period, it's going to be the groups, and groups are columns. So our group trend is going to be from top to bottom. IE decreases. And why is that? Because as we go from top to bottom, our atoms get larger, and the larger they get, the further their valence electrons, their outermost electrons are from their nucleus, so it requires less energy to remove them. Alright? So again, I would just keep track of one of the trends. I just misspelled trends again. If you watch the other video, I forgot a D both times. Anyways, I know it's called trends. So as we kind of summarize this, if you know size, know it really well. Now, if I ask a question about ionization energy, just answer it opposite the way you would size. Okay? So size, ionization energy, exactly opposite from each other.